Hi everyone, uh, welcome to Apache Stratos Hangout. So today we will discuss about how to register Kubernetes host cluster in Apache Stratos and design and implementation. Uh, so I'm Akila Pereira from WSO2. I'm part of this Apache Stratos development team. Uh, so first we will discuss the Kubernetes model classes that we have created for Apache Stratos Kubernetes host registration. So first, we will first focus on the autoscaler service interface. In the interface, we have created several web services for Kubernetes host registration. Uh, uh, First, there's a web service API to get all Kubernetes groups, and also there's another service call to get a specific Kubernetes group with having a specific Kubernetes group ID. And then we have another web service to get the master node of a Kubernetes group. So basic structure is we have several host machines in a Kubernetes cluster. And in this Kubernetes cluster, we have a single master node and multiple slave nodes. So when we are calling the Kubernetes API, uh, we have to first access the Kubernetes master node. So since we are going to access the master node frequently for Kubernetes deployment stuff, we have decided to separate out this Kubernetes master node. So we have created a separate model class for that, and to represent the other Kubernetes slave nodes, we have created a Kubernetes host uh, class. Then again, Kubernetes master is also a Kubernetes host, so there's a child-parent relationship there. And if we take a single Kubernetes cluster, so we have a Kubernetes group class to represent that. So in a single Kubernetes group, there can be only and only one Kubernetes master, and there can be 0 to many number of Kubernetes slaves. So you can see that relationship in this class diagram. And also, if we take a single Kubernetes group, we have defined a port range. So port range is basically the range of ports that we are allocating in a specific Kubernetes host machine uh, to create containers and map container ports to host port. So in a real production deployment, it's not possible to open all the ports in that machine. We have to limit, and also we have to restrict access to certain ports. For example, for SSH, we don't usually allow that to publicly open that port. So in order to enforce that security policies, we have decided to keep a port range that we can use to allocate container port, to map container ports to Kubernetes real host public interface ports. So do you have any questions up to this? I would really appreciate if someone can comment on the Kubernetes model design that we have come up with, because Okay, then we'll move on. So next, we will talk about the sequence of actions that take place when registering Kubernetes cluster. So first of all, we have exposed certain APIs in our REST endpoint web app component. So we'll get to those details later. First, we will talk about the sequence. So first, we will send a post request to this REST API. We have this API to register a new Kubernetes group. And so once the REST endpoint receives this, it will invoke the deploy Kubernetes group service exposed by Stratos Manager. And it will pass the JSON converted serialized JSON object sent in this post request body. So I'll show you an example of this post request later. So once the Stratos Manager receives this invocation service call, it will send that to autoscaler. And inside autoscaler, it will first call the Kubernetes client. So first it will call the CC cloud controller, and it will validate whether this Kubernetes endpoint is valid and active. And if it is active, it will uh, add this Kubernetes group object to in-memory model, and also it will persist that information in autoscaler's registry. So um, so that's the basic sequence of actions taking place when registering a Kubernetes cluster. So this is the REST API that we have developed for this. We have first a post REST API to deploy a Kubernetes group. So it will create a Kubernetes group object in autoscaler's registry, and another REST API to uh, create a Kubernetes host object under a specific Kubernetes group that is identified by Kubernetes group ID stream parameter. And also we have another REST API for updating a Kubernetes master object, and another one to get that is retrieve a list of Kubernetes group objects that is already registered in autoscaler, and another one to get a specific Kubernetes group object, again identified by Kubernetes group ID stream parameter, and also another API to retrieve Kubernetes host identified by Kubernetes host ID, and to delete the Kubernetes group and to delete Kubernetes host.
Hi Attila, I have few comments on the REST API. So you have Kubernetes deploy / group, right? So in my opinion, it's not the best way to do a RESTful definition. So I think we should omit the deploy part. It's, you just post. That means you just create a new resource. And the resource type is Kubernetes group. So the path would be just /Kubernetes /group. Then you add the, it's the post method that defines the, objective. Like, this is a deployment. Do you have any specific reason for using deploy?
Well, I was just following the pattern that was already there in the code when deploying partitions in REST API. Pattern was like deploy / then whatever that is. So
Okay, but I think we need to reflect if it's the case for other methods as well. So that's my opinion on the REST API. So we usually it's not a best RESTful way to specify the verb. You do not
Yes,
include
yes.
verbs in the path. Again, when you have Kubernetes update master, this update operation is already defined in the put method, right? So you don't need to have the update.
Yes. Yes. Thank you, Nirmal. I'll fix that. I also agree with that. It should be like that. Okay. Any other comments? Okay. We'll move on to the
So Akila,
sample.
one other question on the Kubernetes host removal
Yes.
API. So it's slash Kubernetes slash group slash host ID, right? I think it should be slash Kubernetes slash group slash group ID slash host, something like that. Because again, this API operation is not RESTful. Because what you delete is a host, right?
Yes. Yes.
Under a particular group.
Uh, you mean when deleting a Kubernetes host, right?
Yes.
Yeah. Yeah.
Yeah. So, every Kubernetes host belongs to a group, right?
Yes.
Yes. So in my opinion, the pattern should be, so we should access the resource correctly. It should be Kubernetes, then probably group, then the group ID, then the host, then the host ID, something like that. I know it's long, but maybe we need to. But that is the relation, right? You have a Kubernetes group, and under each group you have Kubernetes host.
Yes. Okay. Moving on. So this is a sample JSON definition for registering a new Kubernetes cluster. So here you can see that first we have group ID and description and port range. That is the container port to host port mapping, and Kubernetes master, and then Kubernetes host array. So here Kubernetes host array is empty. Uh, and again, we have a properties array for Kubernetes group object. And here is a JSON definition for registering a new Kubernetes host. So it's basically the same. So we have host ID, the host name and IP address, and a property array. And it is same for uh, Kubernetes updating a Kubernetes host. It is the same. So it will take the host ID from the request body and update a specific Kubernetes host object. And it is the same for updating a Kubernetes master. So okay, that's it for the presentation. So we will now move on to the code. Can you all see the code here? I hope everyone can see the code.
Yeah, we can see it.
Okay, thank you. So here we have this is the um, autoscaler interface. Uh, so we have the services that we uh, discussed earlier in autoscaler service implementation class. So we have methods to get all Kubernetes groups, and to get a specific Kubernetes group identified by a certain Kubernetes group ID, and to get master for a specific Kubernetes group that will return a Kubernetes master object, and to get hosts for uh, the list of hosts for a specific Kubernetes group, and also to add as Kubernetes add a new Kubernetes group. So you can see that it throws certain exceptions in case of invalid Kubernetes group structure.